Now here, let's look at the second part of this question. The sum to infinity of the series can be calculated. We want to show the summation of this can be represented by this, okay, where P and M are constants to be found, right? And K is a positive integer, right? Yeah, it makes perfect sense because you want to start with the kth term of this series. Okay, so let's see. Now, we have to rely on something from the first part of this question. Remember, from the first part, we know that 3r squared plus 10r plus 3 is equal to 0. That means that the common ratio r conforms to this equation. Now we can calculate the common ratio r here. Let's see. 3r squared plus 10r plus 3 is equal to 0. So we have 3r. Now we have 3r plus 1 times r plus 3 is equal to 0. And we've got r1 is equal to negative 1 over 3. And r2 is going to be negative 3. And since we have this very important stipulation here, the sum to infinity of this series can be calculated. Now, if it can be calculated, then we know that the r conforms to this. The absolute value of r is going to be less than 1. So we are going to use this r, and this r2 is negative 3 will be ignored. So now we know that for this geometric series, it has common ratio r is going to be something like this. And since we also know, let's see, from u4 is going to be negative 6, we can also calculate in the first term a. It is quite important. So that, you know, for this geometric series, we know the first term, we know the common ratio, then we know everything about it, right? Yeah. So u4 is going to be a negative 6, and it can be also written as a times r to the power 3, right? R to the power 3. So it is going to be a times negative 1 over 3 to the power 3. So we've got negative 3 is going to be a times something like this, right? Negative 27. So we've got a is going to be 162. So I hope you can see that 162 is quite a special number. By special, I mean that it can be written as something times 3 to the power of something, right? Because we know that, yeah, let's use a different color. 162 is actually 81 times 2, and 81 can be written as something like this part. I hope you can realize that, okay? Yeah, sure. Let's keep writing. Now we've got a is 162 and r is negative 1 over 3. So we've got everything about this geometric series. Now let's observe this summation a little bit. The sum of something like this. We want to expand it a little bit. So the first term of this summation, right? You want to put all the terms, many terms together to have this summation. The summation can be expanded as uk plus u sub k plus 1 plus u sub k plus 2 all the way to u infinity. Now let's see. I think it can be rewritten as something like this. And starting from 1, right? un minus all the way to what is the term that comes before u sub k? It should be u sub k minus 1, right? So k minus 1. Does it make sense to you? Because if you expand this series, you have u1 plus u2 plus all the way to u sub k minus 1 plus uk plus uk plus 1 plus all the way to u infinity. And for this series, you expand it, you've got u1 plus u2 plus all the way to u sub k minus 1. Now if you use this whole thing to subtract this whole thing, you've got something like this. I hope you do it, all right? Yeah, I hope you realize that. So we have, so what is the summation of this, starting from the first all the way to infinity, infinitive number of terms? We've got, we can use this formula, right? A divided by 1 minus r. Why is that? Why is that? Because it has told us the sum to infinity of the series can be calculated, right? Then we use this formula. Infinity, right? Remember? All the way to add up to the infinity number of terms. So for this one, we use this formula. But for this one, it has a limited number of terms. Then we use another formula. Now this n should be all the way to the last one. Last term is k minus 1. So yeah, we can rewrite it as to the power of k minus 1 divided by 1 minus r. And then we want to simplify this a little bit. The denominator will be 1 minus r. The numerator will be a minus a plus a times r to the power of k minus 1. And I think we can cancel out the two a's, right? Then we have a times r to the power of k minus 1, over 1 minus r. Now we've got a, right? We know a, the value of a and r. Let's keep doing. Now we've got 162 times. Now let's observe this term a little bit. So negative 1 over 3 to the power of k minus 1. I think we can rewrite it as negative 1 to the power of k minus 1 times 1 over 3 times to the power of k minus 1. Does it make sense? Yes, because if you look at the final form of something we want to prove, it has this negative 1 to the power of k minus 1. I think we are really close to that, right? Yeah. And now for this 1 over 3 to the power of k minus 1, I think we can rewrite it into something like this. 3 to the power of 1 minus k. So on our numerator, we've got something like this now. To the power of 1, negative 1 to the power of k minus 1 times 3 to the power of 1 minus k. And on our numerator, we've got 4 over 3. Yeah, let's keep writing. Now we've got this time on our numerator 3 times 162 times negative 1 to the power of k minus 1 times 3 to the power of 1 minus k divided by 4. And we know that 162 has a 2 and 4 has a 2. Now we've got 3 times 81 times, now let's move this 3 to the power of 1 minus k here, okay? 3 to the power of 1 minus k times negative 1 to the power of k minus 1. Because like we said, 81 has 3's, has a lot of 3's, right? Yeah. Now we've got our numerator, denominator 2 here. Now for this 81, we can rewrite it as 3 to the power of 4. So 3 times 3 to 4 times 3 to 1 minus k times negative 1 to the power of k minus 1 over 2. Now we've got 3 to the so we've got 3 to the 1, right? 1 plus 4 is 5. 5 plus 1 minus 6 is going to be like 6 minus k times negative 1 to the power of k minus 1 over 2. And maybe we can, yeah, since it asks us to write something like this, then we may want to rearrange it a little bit. We've got something like this in the end. So problem solved. I hope you like this video. So we have shown this